The idea of this project was to implement and evaluate an advanced rendering technique. In this case, I chose to implement screen space ambient occlusion, which is a fast technique for adding soft shadows to corners of geometry. The demo loads in the freely available Sponser scene from Crytek, which was chosen because it provides a good level of complexity to test out various rendering techniques, and it's seen as something of an industry standard. The SSAO effect can be toggled so that you can see the scene before and after. The demo also allows you to tune various parameters to see how they influence the rendering performance and the visual impact. These include the number of SSAO samples, the sampling radius, and toggling the blurring stage. Additionally, the demo also allows you to see the SSAO stages in isolation and examine the G-buffer contents within the deferred rendering pipeline. Screen space ambient occlusion works by sampling the depth buffer around a given screen space pixel to determine if any nearby geometry would reduce the amount of light reaching a given point. Because it only has to work in screen space, this allows real-time performance. Here we can see the amount of samples being changed in powers of 2 from 4 to 128. As we use more samples, the accuracy increases and the quality improves. However, this has a direct impact on performance, which is important to consider when targeting integrated or mobile GPUs. A simple blur effect is also applied after sampling, which reduces the noise artifacts from undersampling. In these final clips, you can see how the amount of ambient light can be adjusted, which reveals 4 point lights. These lights are computed as part of the final rendering pass, which also adds the SSAO component. These were added as a simple example of deferred lighting. Here we can see how the SSAO radius can be adjusted, which determines the sharpness of the shadows in relation to the occluded areas of the geometry. The demo uses a custom self-written cross-platform engine written in C++, which currently runs on Windows, Linux, Mac and Android. The graphics are rendered using OpenGL, and SDL is used as an abstraction layer for human interface and OpenGL context setup. The project formed the basis of my BSc dissertation, which aimed to carry out performance and visual analysis of the technique across desktop and mobile platforms. If you're interested, feel free to download the dissertation or the demos from our website. Thank you for watching, and I hope you enjoyed the demo.